Hey everyone, welcome to another interesting session in your math class. Today we're going to talk about an important topic that forms the crux of a method called as Gauss Jordan Elimination method, right? And this elimination method is used extensively to calculate the inverse of a matrix. So let's go to the whiteboard and understand what these matrix transformations are and what do they exactly mean, right? So let's take a whiteboard and see for ourselves. Let's say we have this equation, a set of equations, like say 2x plus 3y equals 1 and x plus 2y equals 5, right? So in a matrix form, how do we write this? It's going to be 2, 3, 1, 2, right? Multiplied by x, y equals 1, 5. Right? And typically what we do is we hide this x and y and we write it in the augmented form. So it's called as 2, 3, 1, 2 slash 1, 5, right? This is how we use it to solve the equation, right? So this is augmented form. Now let's look at this side once again. Say the first equation, which is like say 2x plus 2y equals 1 and x plus 2y equals 5. That's the second equation, right? So suppose you multiply both sides of the first equation by 2, right? So what do you get? 4x plus 6y equals 2. The bottom one remains the same, x plus 2y equals 5. So now these two are essentially the same set of equations, right? It's just that the first one has been multiplied by 2, has been multiplied by 2 on both the sides, where 2 into 2 is 4, 3 into 2 is 6, and 1 into 2 is 2. So this is essentially the same equation as this one. It's not different. So over here, if we multiply this by 2, then this has also to be multiplied by 2, right? So we can rewrite this as 4, 6, 1, 2, and then this becomes 2, 5. So this remains the same, but then this 2 changes to 4, 3 changes to 6, and 1 changes to 2, right? So essentially this one, this form of the matrix is same as this one, right? So the first elementary transformation is that if you multiply any row by a constant k, right? When I say row, it means both the LHS and the RHS, that the matrix remains unchanged. That's the first elementary transformation, right? Yeah. Now, let's try another thing. Let's say we swap the first equation and the second equation, right? So let's say we do something like this, like say we bring this down and we take this up. So let's say 2x plus, sorry, let's say x plus 2y equals 5 and 2x plus 3y equals 1, okay? So we have taken this to the top and we have brought this to the bottom, right? We have taken the second equation to the top and brought the first equation to the bottom. So that's the only thing we have done. So this change has to be reflected here as well, right? This is now going to become, so 1, 2 is going to go to the top and 2, 3 is going to come to the bottom. So 1, 2, 2, 3. And similarly, 5 is going to go here and 1 is going to come down. So 5, 1. Okay. So that's the second transformation where if you swap any two rows, right? If you swap any two rows of a matrix and if you reflect the same thing on the right hand side, then the equation remains unchanged. So that's the second elementary transformation. And then let's do another thing. let's say we let's rewrite this equation here down somewhere like 2x plus 3y equals 1 and x plus 2y equals 5, right? Now let's say we multiply this thing by 2, okay? Multiply the entire bottom row by 2. So this is going to become 2x plus 4y equals 10, right? 1 into 2 is 2, 2 into 2 is 4, and 5 into 2 is 10. Now, if we add this equation to the above equation, right, we will get a new equation, okay? Okay, so let's say we add this equation to the above equation. Let's say 2x plus 2x gives you 4x. 4y plus 3y gives you 7y. And 10 plus 1 gives you 11. So instead of this equation, the first one, if you use this one, 4x plus 7y equals 11, and then retain the bottom one, right? Or you to retain this one, right? Which is like x plus 2y equals 5. So now you have two new sets of equations. The bottom one remains the same, whereas the top one is nothing else but the first equation. You add to that twice the second equation. So this essentially becomes, so your row 1 gets transformed to row 1 plus twice of row 2, right? That's a transformation. So what's happened here is that whatever you have done on the left-hand side, right? The same thing you have to do the right-hand side as well. So to this 1, you have added 1 plus 5 into 2, which became 11. So now this thing can be rewritten as 4, 7, 1, 2, and then 11, 5, right? Sorry, I think it should be, yeah, I think that's right. Not this thing, I mean this thing. This thing can be rewritten as 4, 7, 1, 2, and 11, 5, right? So that's the third transformation. So what are the transformations? Just to summarize, the first one is interchanging of rows on both sides. So this keeps the equation unhindered. The second one is multiplying both sides of any row by constant. This also keeps both sides. This also keeps the equation unhindered. And third one, adding or subtracting multiple of one row with another row, right? These are the three kinds of elementary transformations, and we'll see how we use them in the Gauss Jordan elimination method to find the inverse of a matrix, right? So the next video is going to be on that topic. So I hope you found this useful. If you have any other topics on which you want to make a video, just let me know in the comments box. I'll be happy to make a video on that, right? So until then, uh, best luck with your studies, and until then, take care. Bye-bye. If you like this video, please press the like button. For more such videos, subscribe to the channel. If you have suggestions for a new topic and would want to see a video made on that topic, please feel free to comment in the comment section below. Thanks for watching the video and see you in another video. Bye bye.